All right, today we're tackling something huge, something invisible that shapes our entire solar system. We're talking about the sun's giant magnetic bubble.
So, let me ask you something. Did you know that you live inside a giant, invisible magnetic bubble? I know, it sounds like science fiction, but it's totally true. Right now, all of us, every single planet, we're all hurtling through space inside this massive bubble made by our own star. Okay, so let's break this down. The sun, it's not just a big hot ball of gas. Nope, it's a magnetic powerhouse. And its magnetic field, it doesn't just stop at the sun's surface. It actually gets blown outwards by this constant stream of particles. We call that the solar wind. And this creates that huge bubble that kind of shields us from deep space.
And this whole structure, it has a name. Scientists call it the heliospheric magnetic field, or HMF for short. Just think of it as the network that connects the sun to, well, everything in the solar system, including us. And honestly, getting a handle on the HMF is crucial if we want to understand our little corner of the universe. So here's what we're going to cover. First, we'll look at the sun's invisible bubble itself. Then, the perfect Parker spiral. We'll dive into what happens with interplanetary weather systems, talk about the sun's 11-year cycle, and wrap up with why the HMF matters to every single one of us. All right, first up, the perfect Parker spiral. We're going to see how the sun weaves this incredible cosmic web. So let's get into the basic shape of the HMF. If you could actually see it, it's not just some smooth bubble. It's way cooler than that. It's like a giant, elegant, spinning web. Okay, the easiest way to wrap your head around this is to think about a lawn sprinkler. You know the kind that spins? The water shoots out in straight lines, right? But the pattern it leaves on the lawn is a spiral. That's because the sprinkler head is rotating. Well, the sun's magnetic field works pretty much exactly like that. So here's the play-by-play. 1, the sun rotates on its axis. 2, it's constantly blasting out that solar wind in all directions. And 3, as the sun spins, it drags its magnetic field along for the ride, twisting it into this huge spiral. We call it an Archimedean spiral, or more commonly, the Parker spiral, named for the scientist who figured it all out. But here's the thing. This spiral isn't all one piece. It's divided into these huge sections. See, just like Earth, the sun has a magnetic north and a south pole. So some parts of the spiral have a magnetic field pointing away from the sun, and other parts have it pointing back towards the sun. And the boundary between these away and toward sectors, it creates this massive wavy surface. It's called the heliospheric current sheet, but it has a much cooler nickname, the ballerina skirt. Seriously. As the sun spins, this wavy sheet sweeps through the solar system. And as Earth goes around the sun, we're constantly dipping in and out of the folds of this skirt, crossing from one magnetic region to another. Okay, so now let's talk about when things get messy. Because that perfect Parker spiral, it's really just the ideal version. In the real world, the solar system is a much more chaotic place. This is where we get into what scientists call space weather. So what happens when the solar wind doesn't flow at a constant speed? Yeah, a big part of the mess is that the solar wind isn't some nice steady breeze. It comes in fast streams and slow streams. So what do you think happens when you've got fast and slow lanes out in space? Well, you've got your slow solar wind moving at around, say, 300 to 400 kilometers per second. That comes from the sun's equator. But then you've got the fast solar wind, which is screaming along at about 750 kilometers per second. That's more than twice as fast. And it blasts out of these darker, cooler spots near the sun's poles called coronal holes. And just like cars on a highway, when that super fast wind catches up to the slower wind in front of it, bam, you get a cosmic traffic jam. These pileups are called stream interaction regions, or SIRs. They basically create these big, dense shock waves of plasma and magnetic fields that travel all the way through the solar system. But the real troublemakers? Those are the solar storms we call coronal mass ejections, or CMEs. Think of these as the hurricanes of the solar system. They are these huge eruptions of solar plasma and magnetic fields. We're talking billions of tons of material just exploding out into space. When one of these things plows through the solar system, it can totally wreck that nice, neat Parker spiral. And yep, these are the main cause of the intense space weather that can actually affect us here on Earth. So all this activity, the traffic jams and the storms, it's all part of a much bigger pattern. The entire structure of the HMF has this rhythm, this 11-year cycle, where it swings back and forth between being pretty calm and being just complete chaos. Check this out.
This is data from the Ulysses mission. So during what's called solar minimum, that's the quiet part of the cycle, everything is really simple and orderly. You can see the fast wind, that's the red stuff, is locked up at the poles, and the slow wind, in blue, is just hanging out around the equator. Nice and predictable. But now, look at solar maximum, the peak of the cycle. It's a total mess, right? That simple, organized structure just completely falls apart. The magnetic field gets super complicated, and you start seeing slow solar wind popping up everywhere, at all latitudes.
And if you zoom out over decades, you can see this incredible pattern. This chart shows the magnetic polarity near Earth. Red means the field is pointing out, away from the sun, and blue means it's pointing in. And look, you can see it perfectly. The sun's entire magnetic field completely flips every 11 years or so, and it lines up perfectly with the sunspot cycle you see down at the bottom. Wild.
Okay, so we've got this giant, spiraling, constantly changing magnetic bubble. But why should you care? What does it have to do with us? Well, it turns out it has everything to do with us. Our place in this bubble is incredibly important.
Here's the most important reason why. The heliosphere, it's our shield. This magnetic bubble is what protects our entire solar system from the harsh environment of interstellar space. It deflects most of the really dangerous galactic cosmic rays. These are high-energy particles from exploding stars and other crazy stuff out there that would otherwise just slam into our planet. So you see, our connection to the sun through this field is a huge deal. On one hand, it's our shield protecting us from the galaxy. But on the other hand, it's also the highway that solar storms, like those CMEs, travel on to get to us. And those can mess with our satellites, our power grids, the whole shebang. So understanding the HMF is absolutely key to forecasting space weather and protecting our technology. And get this isn't some abstract concept. The most recent solar minimum, back around 2008-2009, was the longest and deepest one we've seen since we started sending stuff to space. The sun got really quiet, and its magnetic field, the HMF, was the weakest we have ever directly observed. Ever. And that leads to a big final question. We know the sun has these 11-year cycles, but its activity also changes over much longer periods, like centuries. So as the sun's magnetic activity changes over the long term, how is our cosmic shield going to change with it? What happens if that shield gets weaker? It's a question scientists are working on right now, and the answer is going to be really, really important.